So hello, I'm back. Um, in my previous stream, I just started 40 minutes and I had to go because I had to meet some of my friends. And yeah, it was a good hangout. And now I'm gonna continue where I was. So yeah, I had 20 minutes left, so I'm gonna complete that. So yeah, let me just set the timer. And yeah, I will study until I feel sleepy. So let's see how many hours I can go in my day 9. So yeah, let's just focus. Uh, where I was doing something here, and okay, yeah, I was doing this. Covariance, use this when your dataset include the entire population where population is this and this and this. Understand? Okay. And this is for sample, this is for population. Okay, I need to understand what this means. This this symbol is okay. The symbol in this image is sigma, which means add up a series of numbers. Sigma means add up a series of numbers. Okay, so here is what I and n means in this notation. The meaning of I and n. This is the index or counter variable. I is equal to 1. This is the starting point. the counting began at 1. Okay, the counting began at 1. And this is the ending point. Upper limit, the counting stops at n. How it works? Sample. This is n and I is equal to 1. So if you see this symbol followed by an expression like I, it tells you to plug in every whole number from 1 to n and add them together. If n is equal to 3, you add them. If n is equal to 5, you poke n, and I is equal to 1. Alright, I needed to know this, so that's good. So I also learned it. The meaning of this. It's weird. Anyway, how can I write this? Okay guys, okay, that's it. And then what? Then, so yeah, summation of n where I is equal to 1, x1, and minus this, y1 minus this. Okay, then what? So whatever the n is, we will have to do the summation, and then after the summation, just multiply it, right? Variance square root is units or uses square. Covariance has no square. Variance square roots is units or uses a square because it only looks at one variable. If you do not square the variances from the mean, the positive and negative distances cancel out to zero. Because, okay, covariance does not need a square because it looks at two different variables. These signs are not mistakes to get rid of. They are the exact data we need to show direction. They are the exact data we need to show direction. How it cancels negative signs naturally. Instead of squaring, covariance multiplies the differences of the two variables. Instead of squaring, covariance multiplies the differences of the two variables. Instead of squaring, multiplies the differences of two variables. If both variables, okay, yeah, like the reason why I'm not screen sharing because I'm currently charging my phone. So yeah, maybe I can show this here or maybe here. Okay, just forget it and let's focus on, yeah. So if both variables decrease together, both terms are negative, negative into negative, positive. So why the simple sample formula uses n minus 1? Using n minus 1 instead of n is called Bessel's correction. It exists to fix a structural bias when estimating a whole population from a small sample. Samples underestimate spread. When you collect a random sample, the data points are naturally closer to the own sample mean than they are to the true unknown population, which is this. When you collect a random sample, the data points are naturally closer to the own sample mean. The data points are naturally closer to the own sample mean. When you collect a random sample, the data points, okay, then they are the true unknown population mean. They are closer to the sample mean, not to the population mean. So if the population mean is like originally 5 and I just pick some samples which sample mean is like 3, then the differences of 3 of the numbers and the sample mean is less than the population mean because it is closer to 3 and it is like it is far than 5, and also the same for the 7. If I take random samples and the um, samples are closer to 7, obviously if I sample mean is 7, then the random data points are closer to 7, but the originally the population mean is 5. That means it is far from 5. So to but what if this is exactly 5, but the uncertainty is too much? That's why we just do n minus 1. But okay, now this concept is making sense. In variance, negative differences cancel each other out to 0. Why negative values fail? You run a delivery business, your target delivery time is 30 minutes. Driver A finishes 30 minutes both days, deviation from target is 0 and 0, and driver B finishes in, okay, just 1 minute. So yeah, I just made it 10 minutes, and yeah, I have 10 minutes left for the completion of 1 hour of day 9 study. So let's do this. Imagine you run a delivery business. Your target delivery time is 30 minutes. You track two drivers over 2 days. Driver 1 finishes in 30 minutes both days. Deviation from target is 0 and 0. But driver B finishes in 10 minutes on day 1, which is minus 20 minutes, and 50 minutes on day 2, which is plus 20 minutes. Problem without squaring. If you calculate variance without squaring the deviation, you must add up. Yeah, it cancel out and get 0. And unsquared formula claims driver B has 0 variance, making them look perfectly consistent. This is a massive problem because driver B is highly unpredictable. Squaring it eliminates the negative sign, ensuring the formula. Yeah, covariance scenario. Why negative values are vital. Now look at a real covariance scenario involving an investor managing financial risk. The investor splits money between two business assets. A look at a real covariance scenario involving an investor managing financial risk. The investor splits money between two business assets, an umbrella company and a sunscreen company. When it rains, umbrella sales shoot up 50 plus, but sunscreen sales plummet Plummet means the sales are down and like the consumers are using it less. So it just reduces to 50 uh, in case of the sale. When it is sunny, umbrella sales plummet -50, but sunscreen sales shoot up to +50. Why the negative sign is appropriate, let us look at the covariance calculation for a rainy day. Why the negative sign is appropriate, let us calculate the covariance calculation for a rainy day. Product covariation of umbrella deviation and sunscreen deviation is basically product of this and this, that is minus 2500. So this result is negative. That means whenever it is a sunny day, the, there is a more sale of sunscreen and less sale of, yeah, it is a negative relation. Whenever it's a rainy day, there is more sale of umbrella and less sale of sunscreen deviation. And then the negative sign is exactly what the investor needs to see. It acts as a signal, providing the two investors move in opposite directions, balancing each other out to protect the investor from losing money. If we square the formula, the result would become positive plus 25,000 plus 2,500, falsely signaling that both businesses boom or fail at the same time. Step-by-step calculation. Ice cream versus hot coffee. Hot coffee. Here is a real-world dataset tracking daily sales at a beach cafe to see how temperature impacts different times. Day 1, 30 degrees Celsius. Day 2, 20 degrees Celsius. So at day 1, there is $200 ice cream sales and $50 coffee sales. And whenever there is a temperature, low temperature, which is 20 degree there, and yeah, so there is low ice cream sales because the temperature is low, and there is more coffee sales because the temperature is low. So there is a negative relation, and there is means. So the means of the temperature is basically $25. So the relationship between the temperature and ice cream sales is whenever temperature goes up, ice cream sales up. So this is a positive relation, and whenever temperature goes up, the hot coffee sales goes down. So there is a negative correlation between temperature X and hot coffee. So X and Y has a positive correlation and X and Z had a negative correlation. Step 1 is calculate positive covariance. Positive covariance is temperature versus ice cream. So we subtract the mean from each data point, multiply the pairs, and add them up. Day 1, we subtract the mean from each data point, multiply the pairs, and add them up. We subtract the mean from each data point of day 1. Okay. Multiply the pairs and add them up. So subtract first, and then yeah, subtract. So this is basically X, this is Y, and subtract and multiply. And then for day 2, for day 2, yeah, okay, there is 1 and 2, so there is day 2. Okay, for day 1 and day 2, covariance, this is covariance. So covariance means two things. So two thing means multiplying those two things, but multiplying to who? Multiplying with what? Multiplying with basically the mean and subtract it from this, and mean and subtract this from this. subtract this from this, subtract this from this, and then multiply. And then because it is a summation, so just add up. Okay, again, so first there is a mean, so each data point should be subtracted from the mean. So, no, the mean should be subtracted from each data point. So mean should be subtracted from each data point for these two, and then it should be multiplied of the 5, and there it is 50. So this and this. So what it says, it is 500 for day 1. The simple sample covariance is 500 because n minus 1, and and whenever it is time for calculate negative covariance, if this is a population, then what? Then this is, if we just root this 500, if we root this amount, what we get? If we root 250, then that is 50. But if we root 500, then it comes 22. So the difference is basically 22, not 25, because if we give it a 25, what the hell, bro? This is complicated. So here I need to clear up something, which is this, not this. So yeah, like I was saying something like, whenever it is a population mean, then that is 5, and whenever it is a sample mean, if that is 3, then the data points are closer to 3, and if also it is 7, the data points are closer to 7, but it is far than 5. So if the data points are far than 5, then the result of the subtraction is higher, and whenever the result from subtraction is higher, okay, no, it is lower, and it is higher in term of population. So it is higher in term of population, it is lower in term of sample. So if it is lower in term of sample, then we must do something like, okay, what happens if we just do this? Okay, it is 15. So yeah, if it is 15 into 50 and 22, so population has high, sample has low, but actually it should be higher. So that's why we just made it like n minus 1, which result in 500, and which is higher. So that means I'm closer to the actual result. So that is the logic, but is that really works? Let's find out that. Okay, so where I was here, I was here. So yeah, a negative correlation. Okay, then just move on. In the case of driver's example, calculate the variance and standard deviation and tell me what does that mean, and also give the breakdown, and in the temp. Okay. Variance, drivers B variance and standard deviation. So step by step, 30 minutes. So yeah, so how much, how much? It is okay, this is not easy. Like a lot of readings are available here to go through. Yeah, target mean is 30 minutes, day 1 delivery this, day 2 delivery is this, where the deviation is this, and sum of the square deviation is this. Calculate sample variance, which is this. Calculate standard deviation, which is this. Exactly. So what do these two numbers mean? The variance 800 makes no sense visually because it is a measure of square minutes. You cannot physically picture 800 square minutes. The standard deviation 28 scales it back to reality. It tells you that while driver B's average time is 30 minutes, any given delivery is highly volatile and typically misses that a target by an average of about 28 minutes. So scales it back to reality. It tells you that while driver B's average time is 30 minutes, any given delivery is highly volatile and typically misses that target by an average of 28 minutes. Because the standard deviations are too high? Is that the case? What if the standard deviation is like closer, like, right? If it is, what if it is closer to 50 minutes, right? So is, if it is closer to like 30 minutes, does that, is that closer to 30 or not? Let's see that. So let's assume the it is like, instead of 10 it is 20, and instead of 50 it is like 40. Okay, so if that is the case, then the square of minus 10 is 100, this is 100, so 200. So yeah, 200 here, and then 200, also 200, and then the root square of 200. What is that? Am I going root square of 200 is only 14, and the root square of 14. Okay, what if this is like, this is only 2. What if he is only 2 minutes away? Okay, if he is only 2 minutes away, or 2 minutes or 4 minutes faster, let's say. So 4, yeah, 2 to the power 2 is 4, 4 to the power 2 is like 2 square is 4, and 4 square is 16, which is 20. Okay, now it is like only 4. Standard deviation is 4. The standard deviation scales it back to reality. It tells you that while driver B's average time is 30 minutes, any given delivery is highly volatile and typically misses the target by an average of, okay, an average of this. So 4, if the driver misses out like 2 minutes earlier or 4 minutes late, then it is there is a high possibility that it is like 4 minutes late for every delivery. Okay, but it is not fair because here it is more than 4, or is it? because there it was like 20 plus 20, so total of 40 minutes late, so it is showing like 28 minutes, and here it is like 6 minutes late and it is showing 4.47 minutes. But the case is I don't know the other numbers, right? Should I ask it? My time is over, so let me just update. So I studied 1 hour out of 3 hour for today, and this is my 15th hour completed out of 100 hours of study. And here it is, my CFL level 1. There is 15 hours completed out of my 300 hours. Yeah, so let me go and bring a glass of water and then I will do the rest. So I'm back again. I just got freshen up and yeah. Okay, what I have said is that a correct sentence. I just got freshen up. Is it a correct sentence? Freshen up. I just got freshened up. Yeah, I just freshened up. I just washed up. Freshened up. Transaction. It's done to you to fix the grammar. It like it means I went and washed my face and drink some water and the thing and then again. I just I just got freshened up. I just got freshened up. Okay, yeah. So anyways, um, let's focus. 2 minutes of study. And there's my screen. And then here we go. So I had a question that is, so what if the gap is like 10 minutes from 30 minutes, like 20 minutes for day 1 and 40 minutes for day 2. Then I think the SD is 14. But the actual, if it is a population, then it is 20. So there is like 5 to 6 minutes gap here. So what does it represent actually? And what if it is minus 22 in day 1 and minus 4, oh, okay, not minus, it's just 4 and 4 in day 2. Then it is like 4 point something for SD. But again, the total gap in term of population is 6, but it is somewhere like 4 to 5. So why there is still a gap of population and sample? What if we don't minus it, right? What if we don't minus it? If we don't minus this, then what will happen? There will be like, if there is -2, okay, this is 4, and if there is if there is 4, then that is 16, then this is 20, and 20 divided by 2, which is 10. So this, the hell? Maybe I am wrong. Okay, so yeah, there is an average of actually population standard deviation. So if this is 20 divided by 2, that is 10. Okay, let me ask him the whole thing, because I just wanna eat the whole math. So where I was, here. I can ask from here, I guess. So yeah, so if I just okay, not this one. What if the gap is 10 minutes away? 10 minutes from 30 minutes, then like 20 minutes for day 1 and 40 minutes for day 2. So yeah, where is my note? Yeah, there it is. So 20 minutes, for so yeah, mean is 30, because okay, and the day 1 is 20, day 2 is 40. This should be -20. This is a case, and then there is another case. This is A, this is B. Day 1 is, let's say day 1 is like -2, and this is -28 actually, and this is 34. Then I think the SD is 14. So then it is 200, and for sample it is root square of 200. Then I think SD is though, but in population it is maybe root of 100. So SD is the root of 100. Root of 100 SD is 10, and that is 14. It is 10 and sample is 14. Yeah, now it makes sense. So SD is 10. So here it is like I am giving the sample an edge of increased SD because I don't know the other samples and the population mean might be far from the sample. So to remove the uncertainty, I just took higher sample SD by simply doing n minus 1. But what if I just take the actual population mean as the sample mean by choosing the random samples accidentally correct by chance? Then isn't it a wrong thing to do by increasing the SD by making it n minus 1 for sample 1? Because I might be right and I don't know I am exactly to the population or not. So why am I doing it? And where is the percentage of being right or wrong or being more close or less close of getting a sample mean to population mean? There is a lot of uncertainty. And is that fair to just take n minus 1 based on the uncertainty? What actually that SD means here in term of population or and in term of sample? In this case, And then there is another case where it could be like um, -21. For in day 2 it is like 4 for standard deviation, and point something for standard deviation. Root square of 20. 20. Root square of 20 is root square of 20. 4.47, 4.5. Okay, 4.5 square 20. Okay. It's like 4.5, 4.5. So then it is like 4.5 for the samples SD, and it is 2 point, okay, square root of 10. What is square root of 10? 3 point something. It is 3.2 in term of SD of population. So here is also a gap of population and samples SD, just like the previous one, but the gap is like lesser. So what this mean as SD, tell me that too. So this is a big question, and let me just ask it. If you accidentally pick a perfect sample using n-1, will overestimate the true standard deviation. However, statisticians use n-1 because across all possible random samples you could ever pool, the formula n is mathematically guaranteed to be wrong. However, statisticians use n-1 because across all possible random samples you could ever pool, the formula using n is mathematically guaranteed to be wrong or underestimate. Yeah, like I can be right one time, but I must be wrong in other times on average. While the n-1 formula, it is guaranteed to hit the exact target on average. On average, your first scenario, 10 minutes and 40 minutes. Let's clear up the math for your first case target. Okay, this and this. The sample is, this is for, what the hell? Okay, this is 25. Then why the fuck is this 60? 30 minutes and where it is. This is like driver A. This is here, I guess. Yeah, so the target mean is this. Okay, in this case the mean is 30. Okay, the mean is 30 here. 10 minutes and it took 50 minutes. Target mean. Okay, he actually just gave it a mean. So I am wrong. I am wrong in this case. I have to correct that. So if this is minus 20 and 40, then this is 60. And if this is okay, I am wrong. I had to make it 30 for the mean, right? I had to make it 30. Or what? Or what have I done? So the target mean is like 30. First day delivery time is 10 minutes. Second day delivery time is 50 minutes. So minus 20 plus 20. Okay, so what I did wrong is I just what I did wrong. Correct math is 30, 30. I meant to say it is should be 20 and okay it should be like 20 and 40, which is again 30. Yeah, it should be like 20 and 40. Let's just correct this. 20 and it is 20 and 40. So the gap is like 10 minutes from 30 minutes, like 20 minutes for day minus 20 minutes for day 1 and 40 for day 2. Where the mean is again 30. Okay, it makes sense now. Sample age, so here is. Okay, let's just make it. This is completely wrong. Okay, if I just like 28 and 34, I cannot just write here minus 20. I can just write here the mean. Mean is 30. So this is minus 20, 10. And this is 10. Okay, there is another mistake, that is I wrote here for day 1 he reaches in 20, for day 2 is again. Anyways, okay, so and here the mean is not 30, the mean is 31. But if I just give here like 3 square is 9, and then 3 square is also 9. Okay, just keep something like 26 and 34. Yeah, just take it. Let's do something like complex. It is again mean is 30, and here it is like minus 4. It is like 4. And then this is kind of 16, one shot. Okay, it should be 5 point something, 5.3 or 4, like that. Let's see. 32 root square, 5.65. So it is 5.65 for the sample, and it should be 4 for the population. I have to correct this. So minus 2, not minus 2. Here it should be 4, and here it should be 5.6. Yeah, let's see. I don't know if my voice is coming properly or not. I'm just gonna check it quickly. So, and here, higher. Okay. I think I just need to talk louder, a bit louder would be fine. What I was doing, yeah, I just corrected the query. The standard deviation, what the hell? Where is it? This is here, yeah. So the standard deviation represents the average fluctuation around the mean. The sample version expands this to cushion against the high risk of underestimating reality from a tiny dataset. Even you randomly pull a perfect sample using n-1 is the only mathematically fair approach because you can never know you are right in the real world without checking every single day. Exactly. So the standard deviation represents the average fluctuation around the mean. The sample version expands this to cushion Sample version expands this to cushion against the high risk of underestimating reality from a tiny dataset. Okay, so part 1. Correcting the math for your true standard examples. Thank you for clarifying the numbers. So the mean stays exactly at 30. Let's lay out the precise math for both of the new examples. Let's lay out the precise math for both of the new examples. Case A, case I, large fluctuation 20 and 40 minutes. Mean is this, deviation is minus 10 and plus 10. And so the sum of square is 20, population standard deviation is 10 minutes, and sample standard deviation is 14.14 minutes. So, and case B is a small fluctuation, which is 26 and 34, where mean is 30, deviations or minus 4 and plus 4, sum of squares. Okay, so sum of squares, or like 32. This is 4 because this population, this is sample, this is 5.6. So part 2, what do these standard deviation values actually mean? In terms of population standard deviation, 10 versus 4. Population standard deviation views the 2 days as the absolute complete reality. For case I, then it means the driver's delivery time routinely missed the average mark by delivery time routinely misses the average mark by exactly 10 minutes. Exactly. Oh, in the case of population mean, it misses by 10 minutes, which is actually true. And in term of this, it actually means like misses by 4 minutes, which is actually true. It means the driver is much more consistent. Their time only traced by an average of 4 minutes from the mean. Okay, so it is more consistent, and between these two numbers, this is more consistent and this is less consistent. But both numbers are far from the actual population. So the population might not be this. It might be like something else, which could be higher or lower, and we don't know actually what is the case. So if it is higher or lower, let's check this up. Let's check this out. What if the population is something like just take the population here, like one more thing, and then I think the mean will not be 30. The mean should be changed. Let's take an example here. Okay, do one, and I will know the others. Yeah, guys, this is really interesting. If you just know, you know. So yeah, I won't have to explain how interesting the numbers are if you are getting this point. So if I just take another day, which is day 3 is, okay, this is the sample mean, right? This is the sample mean. And this was the population mean before. But if I take a day 3, then the day 3, suppose this is like it took him 50 minutes. In this case, the population mean gonna be 30, 60, and what the 90 and 110. So 110 minus 3 is 36, which is not a good number. So what I will do is I will make it 40. So, or maybe 42. Yeah, maybe 42. Then it is like 42 and 60, which is 102. And this is maybe 34. Yeah, so this is 34. So what I have to do is 34 minus 30 is 4. So this is 10 square plus, okay, no, not plus. So 10 square, yeah, plus 10 square plus 4 square, 16. So 216. This is somewhat, okay, this is population, right? So I will have to make it divided by 3, which is 8.42, 8.42. And the same, what the fuck? Okay, that's my mistake, because this is not, this was not the correct calculation, because now the population mean is 34 and day 3 is 42. So this should be 42 minus 34, which is 8 square is 64. So 64 plus 64 plus 4, 40 minus 34 is 6. So 36 plus minus 20. Okay, 20 minus 34. If I do it like 34 minus 20, that is the exact thing, or what? 34 minus 20, the hell? 34 minus 20 is 14. Guys, I am so frustrated right now because my sleep cycle is again fucked up, and I just really don't know what to do. Like today again, I slept in the evening. I wake up in night in like 8 a.m., 8 p.m. and my sleep cycle is again fucked up, and I don't know how to fix this because I am not even feeling sleepy right now. I don't know when I will sleep. It is already 4:20 in the morning, and whenever I will sleep, it will be kinda, I think 7 a.m. because I'm not even feeling a bit of sleepiness or dizziness. So I really don't know when I will wake up in the morning. It will be like maybe at least 12 p.m. And that is again a fucked up situation. I don't know how to fix this sleep cycle. I am so much frustrated. Okay, let's just focus. Whatever happens, I will see. Uh this is so frustrating. Anyway, so this is what about 20 minus 34 is okay. So 14 square is basically 196, and 196 plus is 296. 296 root square is 17.20. So if there's a 17.20 and the sample mean is 14, then I think this perfectly makes sense, right? Because the sample were taken like randomly, and let's just take another alternative. If day 3 is basically less than this, then it could be like 60 IT. What if this is 12? This is 12. Okay. If this is 12, I think that will be even more than 10 or 14. This should be at least more than 14. Let's see what happened. Let's see if I can make this less than 14. Okay. So if day 3 is 20, sorry, if the day 3 is 12, then the mean should be uh 60 plus 12 is 72. 72 divided by 3 is 24. The mean is 24, and if the mean is 24, then for day 3 it is 12, and when it is 12 square, it is 144 plus 4 square. And 16 plus, this should be 16, right? This is 16 square, which is, so 416 divided by 3, and the root of this is, what the hell? This is 11. This is 11 point something. I'm giving you some cases. First case is day 1 is 20, day 2 is 40, day 3 is what was it in the previous example? Forty-two and 34, right? So day 3 is 42. Population mean is 34. Day 3 is 12. Population mean is 24. Here, population SD is 11.77. Here, population SD is what was here? I don't remember. What was the population here? Let's calculate again. So it was something like height 64, and this is 3600 and 100. There's 14 square. 14 square is 196. So 296. Yeah, 296 divided by 3, and the root of it is, what the hell? So the population mean here is okay. So the population standard deviation here is 9.93, right? 9.93. Okay, and then there is 11.77. If I take day 1 and day 2 as sample, then the SD is 14.14. Whereas in the case of day 1 and day 2, the population SD is 10. So when I added a population, the SD gets a day more. The populations SD gets lower than the SD when I picked sample mean. Okay, I think I am doing something wrong. Because comparing to population mean is 34. Okay, so I have to do it with the actual population. So if I do it with like if the actual I'm doing the sample from here assuming there is no day 3, and that's why this is 14. But if I just assume, yeah, if I just compare it, then what happens? Like if I do it if I do it like this is 34, 42, yeah. So this is 14, which is 196. So 196 plus 36, which is 132 maybe. 196 plus 36 or 142, 132, right? So 132. And here if I just only root square it, it gets 15, which is not true. But if I do, okay, no, this is true. This, what the hell I'm doing? Okay, I have to do it like this. And now this is 10. Okay, so this is again higher, right? So to make it lower, to make it higher. Population mean is 34. Then it is 296 divided by 3 square root. Feeling overwhelmed because you are mixing up two different things at once. The scale of the data, how far apart the numbers are, and the math of the formula n versus n minus 1. When you discover a hidden third day, there are only three possible things that can happen to the true population standard deviation compared to your tiny 2-day snapshot. The three possibilities of reality. Reality. Think of your 2-day sample 20 and 40 as looking through a keyhole. The gap between them is 20 points. When you open the door and look at day 3, the whole population is 20 points. Okay. And here is what can happen. Possibility 1, your case 1. Third land inside or close to the group, which is this or this or something like this. Balances out, yeah. A clear breakdown of your two cases. The stabilizing day 3, 20, 40, and 42. Your 2-day sample standard deviation is this. Formula use n. Worst assumes the worst because it only sees a chaotic jump from this to this. The 3-day population standard deviation is 9.93. Why it dropped? Day 3 came in at 42. Okay, there is something to catch because on average there is something like whenever there is a population mean of 34, the on average the differences are like here it is 14 and here it is 6 and here it is 8. So 8 and 6 is 14 and then there it is also 14. So 14, so it is 14 but the population standard deviation is giving me 9.93, but the gap is like something like 14. Gap is 14, but population is giving me 9. And sample population standard deviation of our J3 came out. It landed right next to this, which tells the formula, oh, the driver actually hits the 40s quite often. 20 was just one time weird day because the data became more predictable and clustered. The true population standard deviation dropped. Your sample standard deviation successfully acted as a safety cushion that was higher than reality. Okay. So yeah, this is a safer thing. The chaos, day 3. Your 2-day sample standard deviation is 14.14. It still looks at 20 and 40. The 3-day population is standard deviation is yes. So why it increased? Day 3 came in at 12. This is a brand new external. It stretched the boundaries of the data driven further out. And what are you are figuring out the big picture. Your brain is trying to map out all permutations because you are realizing that a sample can never predict the future perfectly. Here is the ultimate takeaway of how sample standard deviation and popular population standard deviation interact across your examples. Your sample standard deviation 14.414 is a guess with a shield up. It uses n minus 1 intentionally overestimate the risk of the 2 days it can see. If the rest of the population is peaceful, case 1, the real population standard deviation will turn out to be lower than your sample guess. Your shield was up, but you didn't need it. If the rest of the population is chaotic, okay, you know what? Let's make it worse. Just the most chaotic thing. Let's do it, guys. Let's do it. So here the sample mean is 14.14. No, the sample standard deviation is 14.14, and here, what if I take day 4 is, let's take something like 30 here. Okay, not 30. Let's take something like 60 here. 60. So if I take 60, then what happens is, no. Let's take something like 90 here, right? Now check this. So 90 plus, you know what, just forget this. Just calculate on our minds. It will make a practice, right? So 60 plus this is 102 and the 90 is 192. So 192 divided by 4, yeah. So it is 48. 48. 48 is mean. So 48 and then okay, so 48. This minus 48 or 48 minus this is 28 square plus 8 square, which is 64 plus 6 square, which is 36 plus 42, I guess. 42 square, which is 2648. 2648. So if I am about to make the population standard deviation, then I will have to divide it by 4 and then make and then yeah, just wrote this. So it is 25.72. So that means it is more clustered. This is the exact moment where the limitation of sampling are exposed. A small sample cannot predict a hidden black swan, even like the 90 on day 4. Even though your sample standard deviation used the n-1 safety cushion to bump the guess up to you know what, let's double it out. What if this is like 60? Because no, what if this is like, okay, it was something like 200, like, right, 200 and root square this. What if we just divide it by, like, yeah, we don't make it divide. What if we multiply this? Then it should be this, right? It should be this, and it should be, I think, 20. It is closer. If we multiply it by like 3, then it is 600 and root square. This is exactly closer to this. So even though your sample standard deviation use safety cushion, the bump, the guess up to this, it still underestimated the true population this, but the sample simply never saw the massive spike of this. Okay, What this scenario proves about statistics, your example is perfect because it highlights a harsh reality in data science and business management. Samples can only judge what they see, but you only look through a 2-day window. The math assumes the world fluctuates between 20 and 40. It has no magical way of knowing a chaotic day like 90 is waiting around the corner. Why n minus 1 is still necessary? Imagine if we didn't use Bessel's correction n minus 1, your 2-day sample population standard deviation would have been just 10 because we used n minus 1. The formula aggressively pushed it up to this. While this is still too low to cover the 90, it is much closer to this than this is. The n minus 1 formula did its job by trying to shield you from underestimation, but the reality was just too chaotic. The law of sample size. This is exactly why a sample of n minus 2 is considered dangerous in the real world. Real world. Law of sample size. This is exactly why a sample is considered dangerous in the real world. To catch rare, massive events like a 90, you have to collect more data. The final summary of your brain's map, you have successfully mapped out every fundamental truth of standard deviation. Look at how all your test cases fit together perfectly. The formula rule for any given sample, dividing by n minus 1 will always yield a higher number than dividing by n. This is our mathematical shield against uncertainty, the peaceful reality. If the hidden population is tightly grouped, like adding a 42, the true population is the shrinks, and your sample field overcorrected. You were safe. The chaotic reality, you are not safe. What the hell? 1 hour just passed? Let me check. Yeah. Yeah, maybe it is past because it is 2 hours of life. So yeah, I am doing it more than an hour, right? Yeah, 51. And then here, 7 minutes left. Yeah, 1 hour passed. 1 hour passed. Like 1 hour and 10 minutes. So yeah, it's not bad. 1 hour and 15 minutes. No worries, 15 minutes much is alright. So, did I take a break? Because where I am right now, I shouldn't take a break, right? Because these calculations are pretty cool. 16 hour. Anyway, just do it, guys. Just do it. I need to feel sleepy, right? I need to make my brain exhausted, like too much exhausted. I need to push my brain. So let's do this. I think 50 minutes will do, because yeah, I did more than what I should be done. So your brain is trying to map out. Yeah, so where I was reading the case 3, right? So the case 3 was exactly here. So day 2 is this, where it still looks at 20. Okay, population is this, where increased. 20 is a brand new external. All right. So it makes sense. I'm not getting here again, so just go right here. Where I was reading something somewhere here, I guess. Yeah, here. This I covered this one, and then this one I just covered this right now. So the standard deviation is 28 minutes. So this is 28 minutes because it is 20 minutes less, 20 minutes more, and that's why this is showing 28 minutes, because if I find out the population mean, then it is 20 minutes, because I don't know what is the exact population mean, and I'm doing it assuming the sample mean. So the population mean might be higher, right? Like, or lower. So if that is lower, then it will cover from this. If it is higher, then it will cover from this. Let's try this. This is the last thing, guys. I won't extend it much. So if the, yeah, just two more thing. If the population mean is like, yeah, just assume the sample mean as the population mean, just +2, and then just -2, right? So if the population here, what is the sample mean? The sample mean is 30. So what if the population mean is 32? So 32. Okay, so this should be how much? 10 and 32. So it is 22, and so 22 square plus I10 square. Is it I10? Because 22, no, it's not I10. It's more than I10. So if it is 32, then 10, 22 square plus 50 minus 32 I10 square. Yeah, exactly. I was right. So 100, yeah, 1000, 1292. So 2 minus 1, that is 1. And if I root this, this is too much. This is 35. It is more than this, right? Okay, what if I take it is more than 30, and the population standard deviation would be something like 32. Also, because it is 32, there should be something more than this. If that is more than this, then it should be less. So the population standard deviation is population mean is 32 and the population standard deviation is should be also 32, right? For 2 number it is 32, but for 3 number is it 32? If the population mean is 5 and the number is like 4 and 6, and the gap between this is 1 square plus 1 square 2 divided by 2 is 1. So yeah, this is 1. And if it is 3 numbers, then it is 15. So 1 is something like 2. 2, so it is 3, so 9. And then maybe something like 8, no, something like 7 and 6. 7, which is 2 to the, or 2 square is 4 plus 4, and another one was 7 plus 2 is 9 plus 6. 7 plus 2 is 9 plus 6 is, then it is 1. 1 square is 1. So 9 plus 4 plus 1 is 14. 14 divided by 3. This is the population standard deviation, which is 2.116. So this is graded. And when it is something like 555 and 5 minus 5 is 0, 5 minus 5 is 0, 5 minus 5 is 0, it is 0, exactly 0. And when it is something like 2, okay, 5, it is let's take it as 3 plus, okay, let's take it as 4 plus 5 plus 6, 15. Yeah, so in case of 4 this is 1 square, so 1. In case of 6 this is 1 square, so 1. And this is 0, so 1 plus 0 plus 1, which is 2. So 2 by 3, and the root of this, okay, this is really less. Root of this is higher than this. Okay, root of this is lower. So this is good. Okay, where I was here. So yeah, I think I shouldn't go more depth. I'm just doing things like uh, like an unsound minded guy. Like I'm just doing random things, whatever just coming in my mind. I'm applying that. I don't know I am doing something wrong or not. So I was here and I did what I have done. I have done this. Making sense of driver base. Why isn't the standard deviation exactly 20? Because we use sample variance n minus 1, which intentionally blows up the numbers to account for uncertainty. Let's look at the two different ways to calculate this to see the exact difference. If this was a population divided by n, then it was 20 because it is a sample dividing by n minus 1. This is 28. What does 800 variance and 28.28 standard deviation 8.28 standard deviation mean to a business owner? The variance. Think of variance as a risk index. If you compare driver B to driver A, the number 800 tells you driver B's schedule is incredibly unstable. While you cannot use the number this logistically, it acts as a penalty score. Higher variance equals a more volatile, unpredictable system. The standard deviation 28.28 because you only observe the driver for 2 days. You do not have the full picture of their life because you only observe the driver for 2 days. Okay, the sample standard deviation penalizes the result, bumping it from this to this to warn you based on this tiny sample. Future deliveries could easily fluctuate widely by around 28 minutes. It tells you the realistic margin of error you need to expect for future deliveries. There is an error calculation then. Turning minus 500 covariance into correlation. Takes the meaningless unit of minus 500 Celsius. We use the correlation coefficient, often writing as what is coefficient, or what often writing as R is the correlation coefficient. Meaningless. Okay. In statistics, a coefficient is a scaling factor. It is a number with no measurement units attached to it. It takes raw, messy, real-world data and compresses it into a standardized boundary like -1 to +1. No measurement. In statistics, a coefficient is a scaling factor. It is a number with no measurement units attached to it. It takes raw, messy, real-world data and compresses it into a standardized boundary like this. So you can compare completely different things. Formula for correlation coefficient. To stripe away the units, you divide the covariance by the standard deviation of both variables multiplied together. To stripe away the units, you divide the covariance by the standard deviation of both variables multiplied together. Standard deviation x and standard deviation y multiply and multiplication of covariance. Okay, the covariance is basically the multiplication, right? the variance of x and the variance of y. I mean yeah, not the variance of x, because the variance of x is x to the power, like, x square. So whenever I'm not doing it as x square, and instead of that x into x, I am giving it x into y, that means this is a covariance. I have a lot more things to learn. Step-by-step calculation for temp X and coffee cells tells that from our previous data we know covariance is this: temperature day 1 is 30, day 2 is 20, mean is 25, deviations squared this, and this sample variance is this. SD is this. Coffee sales day 1 is 50, day 2 is 150, mean is 100. I have to read this. I have to read this. And read this. I have to read this too, right? I have to read this too. There's this and this. Just right now, I am feeling so much tired. My brain is not taking any more information. So I just need a break. But it is like 30 more minutes left. What should I do? 30 more minutes left. I think I should go and fresh, like, just wash my face and drink some water. Yeah, I will come 5 minutes later. Okay, so I'm back. I was just doing a little warm up for my blood circulation so that I don't feel tired and my brain got a refreshment and drank some water. Now let's do this. Yeah, I was in 33 minutes. So yeah, fix the time. And now let's go. In statistics, a coefficient is a scaling factor. It is a number with no measurement units attached to it. It takes raw, messy, real world and data and compresses it into a standardized boundary. Okay, I read this. Step by step calculation for temp X and coffee cells Z. From our previous data, we know covariance is X and Z. Temperature 1, this, temperature 2 is this, and the mean is 25. Deviation squared is this, and this. So the sum is 50. Let me do the math, right? Let me do the math. Okay, I'm gonna do it here so that I can show it. Oh yeah. Okay, so step by step, yeah. So the day 1 it was 30, day 2 was 20, mean is 25. So 30 minus 25 is 5, and 20 minus 25 is minus 5. So 5 square plus 5 square is 25 plus 25, which is 50. So that is it, 50. Okay, so sample variance is equal to 50 divided by 2 minus 1. So which is 50 in case of this. And standard deviation is x is equal to root of 50. Root of 50. Standard deviation x. Okay, sample variance is this, but standard deviation is this. And coffee cells, for coffee cells, this is day 1. Standard deviation of x is this, and standard deviation of z is basically, so mean is this. So 50, 2,500 plus 2,500, 5,000, 5,000. Yeah, so this is 70. So this into this, and how is it minus 500? Okay, because the covariance of x and y. So x is basically how much is x? X is the temperature, z is the coffee cell. So x is how the covariance is calculated here. I forgot. Damn. Here it is. So day 1, yeah, hot coffee, x and z. So day 1 is 30 minus 25, yeah, 5 into 5 into, okay, for 2 days, it calculated for 2 days. So for day 1 is it is minus 250 because 5 into 50, which is 250. For day 2 it is 250 again, because 5, yeah, here it is minus 5 and plus 50, so yeah, overall minus 500. So the covariance of x and z is minus 500, 100, and the standard deviation of x into standard deviation of z is this. So the correlation coefficient is -1. What does -1 mean? The blended unit of this and dollar on top perfectly cancel out the separated unit of c. There is a perfectly negative relation. Okay, that is nice. I got this somehow. I will need to do some more maths and the application of real scenario, but for now I think this will do. And here was another question, which was about the simple average, which is mad. Day 1 distance 20 minutes, day 2 distance 20 minutes, simple average distance is 20 minutes. Mean absolute deviation is mad. If you just take the numbers and look at the final standard deviation of 20, it looks like you just calculated a sample average distance exactly. Population variance and standard deviation. Population variance and standard deviation path. It is 20. Why do both equal 20 here? Because this and this. Let's calculate both methods for this population. Simple average distance, which is mad. Day 1. Okay, in case there is a day 1. Now the mean is 30 minutes here. Okay. So yeah, we just took another example where the mean is 30 minutes, in total 90. So 40, 50. There is a 0 distance, there is 20. Okay, in simple average distance, this is basically mad. Simple average distance is called mean absolute deviation, standard deviation. This is 13.33 minutes. In standard deviation, this is 16.33 minutes, because square and square. Okay, 3 and then root square. Okay, so they are not same number anymore. The standard deviation is 16 is larger than the simple average deviation. Why do we calculate variance then? Because squaring the numbers penalizes big extremes. Statisticians prefer standard deviation over simple average because it heavily flags outliers. Exactly. A single massive delay of 60 minutes creates a squared variance of 3600. A single massive delay of 600 creates a squared variance which blows up the standard deviation and alerts the business owner if something is dangerously unpredictable. Part 2, yn minus 1 and y not n plus 1. Okay, I questioned this, but it was dumb. Your logic is brilliant. If we don't know the other days, couldn't those other days perfectly on time less than, because the distance is more, and to diminish the distance we need to, is it really, we need to minus it, diminish the distance. Okay, so the distance is really not far, distance is closer, so to make it larger we need to minus. Yeah, that is the reason. If we don't know the other days, could those other days be perfectly on time? And your tiny sample is this, widespread around roof center. I know I got this. Because whatever I studied 2 hours today, this whole study was based on this yn minus 1. And there is no question of n plus 1 because we want to make it larger, not smaller, because when we compare the sample's distance with the population's mean, it must be larger, and to but we are taking just the sample mean for the sample data set. That's why the numbers are closer, and because the numbers are closer, the numbers are less, and to make it higher we must divide it by n minus 1 so that there is a smaller number, and when we divide a number with a smaller number, then that is a larger number. So yeah, when we calculate a sample's variance, you are forced to measure distances from the sample mean, not the true population mean. Exactly. Y division by n minus 1 fixes this. Yeah, this logic is here. Anyways, I am completely overwhelmed by today's concept. Like, I went too much depth into it, and I don't know if this will be a good thing for me or not. I hope this will be a good thing. So what it is a statistical method used to map a statistical method. Regression analysis. What it is a statistical method used to map a trend line through data points to predict future values. Why we need it to see cause and effect relationships and forecast an output Y based on an input X. How it is calculated, it uses the least square method to draw a straight line y mx plus b through a scatter plot of data, minimizing the vertical distances from the line to all the scattered points. The logic behind it systematically finds the single mathematical line of best fit. I have to read about the regression analysis. Uh, it systematically finds the single mathematical line of best fit that cuts through data noise with the lowest total margin of error. When it is applied, predicting future sales based on advertising spend or calculating a stock's beta sensitivity to the broader market. Okay, I need to understand this and this. Why we need logarithm? Because of this, why we need calculus? Okay, I'll go through this, but not today. Too much overwhelming. How many? So yeah, it is 14 minutes left today. So I should update my days. I think I should keep it right here. Yeah, the timeline. Oh, day 9. Is it day 9? What the hell? It is what? No way. Did I not change the date? Yeah, I think this is day 10. I think this is day 10. Yeah, it's day 10. I needed to change this. 16th hour. It's 10 and 17. On the 15th hour, what did I study? Correlation, covariance, correlation, and coefficient. Then I studied about SD of sample and population concept. Then something. Yeah. This is actually a good thing. Like if I want to bring myself here, okay, let me just fix my camera. But wait, I had only 15 minutes left, right? Or it is showing different thing. Yeah, it is showing from the beginning. Okay, when I just change the scene, it gets restarted, right? Gets restarted. So I needed to fix the time. Let's see what can I do. I don't want the timer to be changed so much. Otherwise, there is no use of scene 2. I don't need this because I can just turn this, turn off this. Yeah, this is better. I don't need this. Anyway, I had something like 15 minutes left. So let's complete that. So the concept of regression analysis, I have to understand from here to all of this, and I will do this later. So now what can I do? Just review. Yeah, last 15 minutes should be reviewed what I have studied in the previous days. So previously I was studying in here, if level 1, and then here, yeah. Then I was somewhere like here. So TWRR, MWRR, then arithmetic mean, geometric mean, and harmonic mean. I have to understand what is geometric mean. Yeah, this is really important. And then harmonic mean. There was some learnings like what, why, how, login, when, oh, what was this? Was about okay, when is what is it? Arithmetic average is the mathematical average of data set, center of gravity of the data. Median is the middle number when a data set is arranged in order from smallest to largest. Yeah. Mode is which number is the most repeated number, most frequent number. Range is the simplest measure of how spread your data is. Why we need it to quickly see the absolute boundary stretch of your data, the minimum number and the maximum number. How it is calculated? Subtract lowest value from the highest value, maximum minus minimum. The logic behind it, it ignores the middle completely and isolates the two furthest opposing extremes to show total width. Okay, variance, standard deviation, covariance, coefficient, regression. What the hell? This is the thing I was doing here, right? Yeah, so this same thing. Okay, and then correlation versus covariance, and then okay, this I did something wrong. That is, I would have to do this just here, right here. Short selling, hedge fund, index, ETF, fiat money, merchant bank, investment in commercial bank, debt instrument, bond and debenture, brokerage house, bond versus treasury bond difference, treasury bill, bill of exchange, and corporate bill, commercial paper difference. Okay, let's do something. Just a minute. Okay, my audio was off. So yeah, what I have done, I just turn on my camera, and then I was thinking about exploring Khan Academy, which is a learning platform, and let me make it 10 minutes. So I just sign up there and let's just explore it, because I see some important topics here which are all free, I guess. Credit crisis. So I can have a good amount of knowledge from here. Short sell basics. There's important topics here. Compound interest. Rule of 72 for compound interest. Present value. Yeah, this is really important. Accounting and financial statements. Cash accounting. There are some important thing here as well. Okay, stock and bonds. Bonds versus stock. Shorting stock to shorting stock. Short selling. A lot of important topics here. Current economies. Unemployment. And what about the English learning platform? Khan Academy. So math. Okay, just let's go here. And then personalized Khan Academy. Okay, there's a lot of things to study. Financial literacy, personal finance, vision career, like all of these are important. English language arts. Okay, let's do this. Let's see all the topics. Early math review. I don't need this. 8 trade math. I need arithmetic, basic geometry and measurement. Do I need arithmetic? Yeah, let's skip it. Geometry and measurement. Yeah, basic. I need to know basic things. Algebra, algebra 1, algebra. What? Track more than 9 courses for you yet. Okay, I cannot select more than 9 courses. Okay, no worries. Then just remove this. And remove this. Computing. I don't need computing. Art, economics, finance, and capital markets. Yeah. There is no GMAT preparation. I needed that. Okay, I need this. Can I skip this and do this later? Because okay, I need statistics and probability. Like, this is really important. I need to go through this. But where it is, like finance and capital markets? Where is this section here? Finance and capital market. Finance and capital markets. Where is this? I don't find this. Like, if I just go here. Okay, in the economics section, finance and capital markets. Here it is. There it is. Okay, what is in the economics section? Economics. Where it is? Macro. There, it is not in a good way here. Let's see here. In the economics section, there is economics. it is not that much to explore. Go here and select one of this. Macroeconomics both. Just select both and see what it is. Yeah, select all of this. Let's see what is the differences. So here it is: macroeconomics, basic economic concept, and consumer theory at the end. um where is the others? The same thing or different? I don't know actually, but I'm not focusing on economics right now. So yeah, this 5 I will go through this. But yeah, now as study time is over, so I'm gonna just update this as completed my 3-hour study today. And this is my 17th hour of study. And then this is 17 here. And now what I'm gonna do, I'm gonna play some chess. So it is chess time, and this is break time. Okay, 60 minutes of chess. No, 40 minutes of chess. And this is my break time. That's it. Okay, so I didn't share my screen, right? So I couldn't show this, but this is really efficient to learn finance and capital markets, like these topics. And most importantly, unit 9 options, future, like these options like call option versus leverage, put versus. So these are like super important to me, super interesting to know and explore. So I will go through this. Yeah, and I just picked some courses here, 5 courses which I think is necessary for me to know, like this personal finance, this statistics and probability, this, and then this statistic essentials. So yeah, I will know about this later and I will study this. But now it is chess time, guys. Let's do this. Let's play some chess. Then I have to. Yeah, new game. Let's play it. Oh fuck. I don't have time. What happened? Fuck. Fuck. Could have give it here. I am just playing like a shit. You just simply take this, right? You will take this. Bro, take this. But we just played on time. I just lost 3 in a row, guys. That's so humiliating. 4 in a row. Just lost 4 games in a row. Five in a row. Let's see how much I can do. I will go into 100. So shameless. Shameless. Fuck, bro. Fuck. I'm in 100. unquote. For 6 or 7 games, I just won one. I'm gonna lose this. I just messed up, bro. Blunder of the day. That was intentional. Hey. Hey, so no way, no way. But okay. Okay. No, 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 I can't do it. Fuck. 5 seconds. The hell? He's just playing randomly. The fuck? second. Abe, bro, play. Fuck, he missed it. He missed it. No. Oh no. 6 seconds left. What? How did I win that? Oh, I could take it. Fuck, why? Okay, okay, yeah. It was a check. What the? My knight was here. Fuck. But I am good. I'm losing this. Mm, mm, mm. Mm, 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 mm. Is there anyone watching? Ah, I think yeah, my time is over. I will come later because today's session is over. Okay, you are watching. Should I play some more matches? Do you play chess? Do you play chess? You can send me a challenge. This is the username. It took 12 seconds for the first move. Anyways, he's targeting this, so here it is. Yeah, target this. I thought we were on the quant path. Okay. Yeah, I was, but I studied 3 hours, so I thought let's play some chess. But yeah, maybe after the match I can do those stuff. He just took my Okay, he took my pawn. Why he just took so much time for this one move? Okay, you can tell me about yourself, like what do you do and what specific thing you have interest in the quant. I was planning in my next video about the regression analysis and yeah, the concept of regression analysis, because today's lesson I just cleared some concept of covariance and standard deviation, more specifically that where it is, yeah, here. So this, yeah, like the meaning of standard deviation, what that standard deviation value means in the real life example. I just tried to find out those concept in depth, and like the reason why we subtract -1 from n in the sample variance. Yeah, so those reasons I just tried to find out. Also, I was seeing something here. Where it is? Yeah, something here. Like this course, this is totally free, and I'm just planning to do all of this because this seems really interesting. And the most interesting part is this, because I really want to understand the depth of options, swap, future, forwards, like the derivative part. I think they covered it here. So I think I can go through this in my next lesson too. Okay, let's do this. Let's do this. This one. I have a lot of questions from this part. So let's find out. Let's study 1 more hour for today. A statistical method used to map a trend line to data points to predict future values. Let's understand this first. To predict future values, a trend line statistical method used to map a trend line to data points to predict future values. Is there any image? Okay. Linear trend model. You can write in the comment section what maths, um like in which type of math you are interested in. Well, regression analysis. So yeah, this is some data points. There is a line which is a linear regression. Okay. Simple linear regression. There is a okay, these are data points. Line of best fit, which fits these points best. And then the thing we want to explain. Okay, this is dependent on this independent factor we think might influence the dependent variable, and confidence band 95%. If a data point falls outside these lines, your 95% sure thing is something special about it. If a data point falls outside these lines, you're 95% sure you are 95% sure there is something special about it causing it to better or worse than others. An outlier worth understanding. Okay, this means something like an outlier. If any data point, yeah, this goes too far from this. And if you only had data on x, this line provides y, this line provides y. Okay, this line provides your best estimate of y. Yeah, okay. X could be used as a sugar surrogate or forecast of y. 77% of the variance in y is explained by x. Below 30% means they are hardly connected. Above 95%. Okay, let's just take it. Copy. So yeah, from here I'm just gonna study regression. understanding. Okay. Type of regression models: linear, polynomial, logistic. So there is a vast topic of regression. What is regression analysis? A set of statistical processes of estimating the relationships. Set of statistical processes for estimating the relationship between a dependent variable, okay, outcome or response, and one or more independent variables. So something like correlation is here. Relationships between a dependent variable and one or more independent. So there is multivariables, predictor, covariates, explanatory variables, or features. Okay. Why we need it: to see cause and effect relationships and forecast an output y, which is dependent, based on an input x, which is independent. Okay. How it is calculated: it uses the least square method, partial least square method. Okay, I need to understand this. Draw a straight line. Y is equal to mx plus b, which is the formula of defining slope. Okay, so I was having a conversation. Well, yeah, where I was. Okay, I was in this formula y is equal to mx plus b, which is a formula of slope. Okay, through a scatter plot of data, minimizing the vertical distances from the line to all the scatter points. Okay, I didn't understood this at all. The logic behind it systematically finds the single mathematical line of best fit. Okay, got this. That cuts through data noise and with the lowest total margin of error. When it is applied, predicting future sales based on advertising spend or calculating a stock's beta sensitivity to broader market. Okay, let's just take this. I need to know a lot of things from here. Do I need this to understand first? There is some beta 0, beta 1 concept. Regression line y is equal to b0 plus b1. Maybe these are some independent variables. This is dependent. The mathematical best fit line used independent variables x. I will read this, but let's do something. Okay. I have to understand all of it. So first, what it is. Why is this in like flat formatting? The hell? This is flat. Okay, no problem. What is a statistical method to map a trend line through data points, predict future values. A trend line to predict future values. Okay. What kind of future values it is talking about? Need real scenarios to understand, and then why we need it to see cause and effect relationships and forecast an output based on x and y. How it is calculated, it uses the least square method. Okay, and then what is least squared method and what is partial least square method? What is the difference and what which one used here in RA regression analysis? Okay, the next question is about what is beta that B0 B1 thing, what it is, what does it represent, why we need it here. The next question is about scatter plot of determinism, the vertical distances from the line to all the scatter points. The logic behind it is it systematically finds the single mathematical line of best fit that cuts through data noise with the lowest total margin of error. Okay, how it maintains the error, how it is calculated, what is the formula, what things used here, breakdown of the formula, up and down, result, effect on it, on cause, effect on real scenario. Is there any other statistical thing used here, like coefficient or correlation, covariance, or ST? Then when it is applied, predicting future sales based on advertising spend or calculating a stock's beta sensitivity to the broader market. Okay, and then I need to read this and let's see what more question I have. Dependent variable is y, the primary target you are trying to predict or understand, house price or sales. Okay, independent variable is x, the factor or features you believe influence y, square footage or advertising spend. Okay, regression line, the mathematical best fit line used in Linear regression where b0 is the intercept. Okay, it is the slope's intercept and b1 is the slope. Got this. But I need to understand this deeper. Explain me this in depth. And what about y equal to mx plus b thing? This log thing I want to understand totally with real examples and the changes in it with different scenarios. There's a lot of things. Should I just give it once or like one by one? Because I think more than 10 questions is here. Okay. I think I'm not doing it that much structurally because maybe I can do this in a more structured way, right? There is a lot of things. If I don't list it down, I won't remember it. I think I should take a day to just review all the thing and structure it one by one. And yeah, and there is a like the answer of this question. The questions should be listed here so that I can find it. Okay, maybe I will review it later and just list all the questions here. Regression analysis. Okay, not only regression analysis, there is more than that, because regression analysis where there is beta slope least square method, LSM least square method. What else? Okay, difference. Okay. Scenario, best fit, intercept, slope. Yeah, I think these are the main things. Okay, and then what else? Utilizes two or more independent variables to predict a single continuous outcome, useful when multiple factors are at play. Logistic regression used when the dependent variable is categorical. Okay, I need to understand this more depth. Explore how these statistical methods work in real scenario, or to find step-by-step guides, then visit this or check out Corporate Finance Institute. There is a website, I just forgot. There is a American website. Okay, my friend told me about that. I will ask him later. Like there is all the financial terms explained in a structured way, so that could be helpful. In statistical method regression analysis, okay, these are just Okay, a lot of things are here. Oh, Sebastian Taylor. Only three: linear regression, multiple linear regression, and non-linear regression, linear model assumption, simple linear, intercept, slope, residual, error. Common types of regression. Let it be generate, and I will just read this. Evaluates the relationship between exactly one independent variable and one continuous dependent variable using a straight line, and utilizes two or more independent variables to predict a single. Utilizes two or more independent variables to predict a single continuous outcome, useful when multiple factors are at play. Logistic regression used when the independent variable is categorical. Logistic regression when the independent variable is categorical, like true or false, yes or no, like binomial answers type of thing, rather than continuous predicting or probability. Okay. Okay, it is big. It is big. Like it is too much broad. Steep positives. Okay, there is an explanation of slope. Steep positive, and this is negative slope. Steep means like this. And what does this call? Steep slope versus gentle slope. No, steep flat slope. No, shallow slope. I think this has a different name. Okay, okay. More steep, more steep, less steep. Maybe kind of thing. Shallow steep, zero slope. Okay, more steep. What if this is like this? The negative relation. Okay, okay, okay. Where it is? Average slope, steep slope. Okay, low slope. 4 different types of slopes for direction: positive slope, negative slope, even steeper, not steep, a little steeper. Okay. Can a negative line be steep? Okay, okay. Oh, let's go one by one. There is a lot of things. The future values and real world scenarios. When we say regression predicts future values, we mean it forecasts a continuous numerical output that you do not yet know. It can predict a literal future point in time or an unknown value based on a given condition. Scenario I, real estate. You want to know what a 300 square feet house will sell for. You want to know what a 300 square feet house will sell for. X is equal to square footage. Y is equal to price. Regression model. 300 square feet. Let's take an idea about 300 square feet house length. How many mid-sized room can be there? A lot. This is 300, 3,000. Yeah, 3,000, not 300. So it's a bedroom. It's a drawing room. There is a opening floor. There is a second bedroom, and here is a guest. Okay, one, two, three, 1, 2, 3, 4, 5, 6, and the kitchen maybe. It's really big. It's really big. 1,000. This is 1,000. Okay, so 1, 2, 3, 4, like 5 rooms. 1, 2, like 4 rooms. Hardly 5. All the rooms are small. 1,300 feet room length. 20 square foot studio apartment. 300 square feet. 1 feet. Length. Square feet. Room width and length. 12 feet into 25 or 15 into 20? 15 feet. I think my room is like 12. 1, 2, 3, 4, 5, 6, 7, 8. 12 into 12. 12 into 15. 180 square feet maybe. So 3,000 square feet is big. Okay, so where I was. I was here. Okay, we'll sell for. You want to know what a 3,000 square feet house will sell for? X is equal to square footage and Y is equal to price. The regression model looks at past sales data to predict the value of this new house. Scenario B, business growth. A company wants to know if we spend 50,000 on Instagram ads next month, what will our revenue be? X is equal to ad spend, Y is equal to revenue. And scenario 3 is agriculture, predicting crop yield, which is Y, based on the amount of rainfall a field receives. Least square versus partial least square PLS. Ordinary least square and partial least square. The difference and which one we use here. The standard most common method used in basic regression analysis. How it works, it looks at the scatter plot and draws a line. It looks at the scatter plot and draws a line that minimizes the sum of the squared vertical distances errors between the actual data points and the line. When it is used when you have a few clean independent predictor variables. Instead of finding a line directly through the raw data, it compresses a massive number of highly correlated X variables into a smaller set of brand new independent. I will read this later because my brain is just jammed for this to understand right now. Continue from here. Is there any viewer here? I don't know. No one is watching. Okay, that's even better. So I'll just continue. When it is used when you have more variables than data points, genomic data with thousands of genes but only 50 patients, or when your X variables are highly overlapping. Understanding they are exactly the same concept, just written in different formats. In high school algebra, you learned y is equal to mx plus b. In advanced statistics, it is written as y is equal to b0, which is intercept b1x plus, or this is intercept. This is what? Here is the precise mapping and what they represent using a food truck selling ice cream. Example, x is equal to temperature in. Why am I not sleepy? That's the main concern for me. Why am I not sleepy? I should feel sleepy. You them. We need them because they form the predictive equation. If our model calculates b0 equal to 10 and b1 is equal to 5, our predictive engine outcomes. Tomorrow is forecast to be 20. We plug in the should go through some simpler things, I guess, because this is too complicated right now for me to understand. And there is 20 minutes left, so maybe I should do something else. What should I do? What should I do? I don't know. Let's just go through this. Where is it? Where is it? What I want to do in this zero stuff. Okay, compounding interest, and then have a little bit of discussion of a very quickly kind of approximate way to figure out how quickly something compounds.
even if etc. To that. So it starts at the tree.
Fast. Hello, hello, hello.
So it starts at the tree. And it see here, it's three, just let's see. So the slopes which indicate so it is. So it it's three, let's see. So slopes which indicate so it is. B. So starting stay set stay just stop
Search volatility or risk compared to the overall market. The beta of the market is always set at 1.0. A beta greater than 1.0 means the asset is more volatile than the market. Less than 1.0 means it is more stable. 1. The asset moves exactly in line with the market. If the market drops, this asset likely drops. 2. The asset is more volatile than the market. Means it is more stable. 1. The asset moves exactly 0. A beta greater than 1.4. Search volatility or risk compared to the overall market. The beta of the market is always set at 1.0. A beta greater than 1.0 means the asset is more volatile than the market. Less than 1.0 means it is more stable. 1. The asset moves exactly in line with the market. If the market drops, this asset likely drops. 2. The asset is more volatile than the market. Read Aloud is a Chrome and Firefox extension that uses text-to-speech technology to convert web page text to audio. It works on a variety of websites, including news sites, blogs, fan fiction, publications, textbooks.
Read Aloud is a Chrome and Firefox extension that uses text-to-speech technology to convert web page text to audio. It works Read Aloud is a Chrome and Firefox. Read Aloud is a Chrome and Firefox extension. Read Aloud is a Chrome and Firefox extension.
Read Aloud is a Chrome and Firefox extension.
Read Aloud is a Chrome and Firefox extension that uses text-to-speech technology to convert web page text to audio. It works on a variety of websites.
Read Aloud is a Chrome and Firefox extension that uses text-to-speech technology to convert web page text to audio. It works on a variety of websites, including news sites, blogs, fan fiction, publications, textbooks.
Read Aloud is a Chrome and Firefox extension that uses text-to-speech technology.
Read Aloud is a Chrome and Firefox extension that uses text.
Read Aloud is a Chrome and Firefox extension. Read Aloud is a Chrome and Firefox extension that uses text-to-speech technology to convert web page text to audio.
Read Aloud is a Chrome and Firefox extension that uses text-to-speech technology. Read Aloud is a Chrome and Firefox extension that uses text-to-speech technology. Read Aloud is a Chrome and Firefox extension that uses text-to-speech technology to convert web page text to audio. Search results. Beta is a financial metric that measures an asset's price volatility or risk compared to the overall market. The beta of the market is always set at 1.0. A beta greater than 1.0 means the asset is more volatile than the market. Less than 1.0 means it is more stable. 1. The asset moves exactly in line. Search results. Beta is a financial metric that measures an asset's price volatility or risk compared. Search results. Beta is a financial metric that measures an asset's price volatility or risk compared to the overall market. Search result. Search result. Search results. Search results. Beta is a financial metric that measures an asset's price volatility or risk compared to the overall market. The beta of the market is always set at 1.0. A beta greater than. Means it is more stable. 1. The asset moves exactly in line with the market. If the market drops, this asset likely drops. 2. The asset is more volatile than the market. For example, a beta of 1.5 indicates the stock is more volatile. If the market goes up, this stock theoretically goes up. Tech stocks frequently fall into this category. 3. The asset is less volatile than the market. Beta is a financial metric that measures an asset's price volatility or risk compared to the overall market. The beta of the market is always set at 1.0. A beta greater than means the asset is more volatile than the market. Beta is a financial metric that measures metric that measures an asset's price volatility. Beta is a financial metric that measures an asset's price volatility. Beta is a financial metric. Search results. Beta is a financial metric that measures an asset's price volatility or Search results. Beta is a financial metric that measures an asset's price volatility or risk compared to the overall market. The beta of the market is always Search results. Beta is a financial Search results. Beta is a financial metric that measures an asset. Search results. SA financial metric that measures an asset's price volatility or risk compared to the overall market. The beta of the market is always set at 1.0. A beta greater than means the asset is more volatile. Search results. Beta is
Okay, that is it. I think I should go now because I started one more hour. I know this hour wasn't so much effective, but yeah, I found out something that I can use whenever I am so much tired to read out. I can just use this. So this will be really helpful, and yeah, it's time to go. I'm just updating this. Yeah, this, and then this should be 18 hours, and this should be 18 hours. So yeah, that's it. Finally, I have to update this. 18th hour is about the regression analysis. So yeah, this is it, and exactly here I will list this later. Okay, so yeah, it's time to go, so goodbye.